One is all about division of real numbers. Now, we do talk about the word reciprocal in this lesson, but I'm going to tell you you might want to pause and look at this now, or you might want to do some of them in action first and move back to the screen. I think if you see it in action, it will make more sense, and this tends to be just a little bit wordy. So I'm going to move on to the next screen. And it says you can use a reciprocal to write a division expression as a product. And again, when you see this in action, I think this is going to make much more sense to you. So we're going to move along. Just give you can pause if you want to. So example 1, dividing real numbers. So we're going to start out with just dividing. In letter A, we have 10 divided by a -2. So we're going to go back to our rules of multiplication. They also apply for division. We have a positive and a negative, so our answer is going to be negative. Let's change from that green color. I think the blue shows up much better. Positive and a negative, so we know we're going to have a negative. Oh, my goodness. We're having some problems this time. All right, let's try it one more time. A positive and a negative, so different signs, going to be a negative, and then 10 divided by 2 is 5. So you notice first I applied the rule to get the right integer symbol, and then I just ignored them and went ahead and did the math. Now the next one, they threw in a mixed number. So we have -39 divided by a -4 1/3. If you remember, there is no easy way to divide by mixed numbers. So our first step is we have to change our mixed number to an improper fraction. And this is where our reciprocal will come in, but I think if you see it, it'll make more sense. Changing this to a mixed number, or to an improper fraction, I'm going to do the -4 times 3, because that means I have 4 full pies of 3 pieces, meaning I have 12 pieces. So -12, and then I have one more. So that's going to be a -13 over 3. Now, when I am dividing, it means I'm going to multiply by the reciprocal. So I'm going to do a -39, but I'm going to multiply it by the reciprocal so that it still stays as a negative, but I'm going to flip the numerator and denominator around. Now I can go ahead and I can give a denominator to my 39 if I'd like. And I'm going to switch colors now so that you can see. Before I multiply, it's always best to go ahead and reduce. So 13 can go into 13 once, and it can go into 39 3 times. Now, I'm multiplying a negative times a negative, so that means I'm going to have a positive answer. 1 times 1 is my numerator, just means that I have a whole number, and 3 times 3 is 9. Whoops. Sorry about that. All right, so we reduced. Anything over 1 means it's a whole number. And then we looked at the signage. Negative times a negative. Negative times a negative gave me my positive. And then 3 times 3 is 9. Right? Dividing real numbers. Now, normally, we say that you should not have a fraction within a fraction. So I'm going to rewrite that, and I'm going to write that as -1/3 divided by 4. Now our rule with fractions is multiply by the reciprocal, but that's for this part. Divide changes to multiply by the reciprocal. So I'm going to leave my -1/3, but I'm going to multiply that by the reciprocal of 4. Let's give it a numerator so we can see it easier. Denominator. So that's going to flip. So now we have multiplied by 1/4. Let's see if I can get you a better fourth in there. 1/4. Now I have a negative and a positive, so my answer is going to be negative. I can't do any reducing, and so I multiply the numerators, 1 times 1, and I multiply the denominators. My answer there would be a -1/12. When I look at the next one, rewrite it first of all as a division. That's not very easy to read. Okay, it was a negative 3/4, much better. So I'm going to leave the first term, multiply by the reciprocal. It's still a negative, but this time it's 4/3. I can put a denominator on that one if I need to. Negative times a positive is going to give me a negative. 1 times 4 is 4. 1 times 3 is 3. So I get a negative 4/3. Now you can leave it like this, or you could change it into negative 1 1/3. I would accept either answer. Now we're going to talk about algebraic expressions. And again, I think if you see it applied, it's going to be easier. So you could pause this and look at it later, or pause it to just see it before you keep going on with the recording. I will call your attention to this part here. And we're going back to our rules. The quotient of two numbers with the same sign is positive, and opposite signs are negative. So we're still applying the same rules that would apply in multiplication. Remember, that is different when you're finding the difference, adding and subtracting. So, using the distributive property to simplify an expression. When we're looking at example 2, we can actually look at that as two separate parts of an equation. So mine's going to look a little bit different than the one in the book. I'm going to first of all just do the first term, 32x, and I'm going to divide that by 4. I'm going to keep my sign, and I'm going to put my next term, 8, but that also needed to be divided by 4. So in a way, this is like the distributive property. Now I'm going to reduce both of these, and I'm going to find that 4 goes into 4 once, 4 goes into 32 8 times. So my new term there is 8x. I'm going to still have a negative, and 4 goes into 4 once, and 4 goes into 8 twice. So I have 2 over 1, which would be 8x minus 2. And this is my simplified expression. Now the book uses the 1/4 and multiplying it through, but I think it's a little bit easier if you just separate it into two separate fractions. Just don't forget to keep the sign with that second term. So this time we're going to evaluate an expression, so we have some substitution to do. So negative 2a over a plus b. Let's just do the substitution first, and I'm going to do it just right next to it first. So negative 2, my a is negative 2, and that's going to be all over a plus b, so negative 2, they're trying to mess you up with the different operations here, plus a negative 3. Seeing if they can mix you up with your rules. Multiplying, I have a negative 2 times a negative 2. Same sign makes it positive in multiplication. When I am looking at addition, I have negative 2 plus another negative 3. I'm combining those. So same sign, you keep the sign, and you go ahead and add them. So I get a negative 4/5. Now you'll notice when we did that, the negative showed up in the denominator. This is correct. Another way you could write this is just to put the negative in front of the whole fraction there. Or another way to write that is a negative 4/5, where the negative seems to be attached to the numerator. All of these are the same value. They're the same value because one of the terms is positive and one is negative. So you have different terms or different signs, so it's always going to be negative. Now we have A done already. Let's go ahead and try B. I'm going to move B over here a little bit. So I have negative 2. We're going to apply all the rules you've learned. That's going to be squared minus 4. And that's going to be over B, which is negative 3. Negative 2 squared would be like negative 2 times negative 2. They're both negative, so it's going to make a positive. Or you can look at Your exponent is an even number, so it made it positive. So now I have 4 minus 4 over a negative 3. Now my numerator turns into 0, so that can just mean you have 0 pieces out of 3 or negative 3, so that means you just have nothing. So that's a 0. If the numerator is the 0, then it makes it 0. When we go to letter C, we're going to substitute negative 2 in for A. We're going to do 3 plus, and we're going to substitute in our B, which is negative 3. Now, simplifying that, negative 2 as our numerator, but 3 plus a negative 3 would leave me 0. That's telling me I have a pie that is cut into 0 pieces. How many pieces do I have? I don't have any pieces. It can't happen. So this means this is undefined. You might want to add that to your notes that when the 0 is in the denominator, it's undefined. When the 0 is in the numerator, that just makes it that the answer is 0. There's that good old velocity again. I'm not sure if by the time we get to this lesson we've been to Swiss Valley or not, but you will be calculating the velocity and recording it at Swiss Valley. So they gave us the formula again that velocity equals displacement divided by time. So in this one, we want to find out the velocity. What is your velocity? So we're going to look for V. And V equals the displacement. And the displacement is going to be what we are descending. Displacement is what's changing. So we're descending. So I put a negative because I'm going down. Negative 500. And time would be the 40 seconds. Now I want to simplify that. I can put that into my calculator. 500 divided by 40. I have a positive and a negative, so my answer is still going to be negative. And your answer should come out to be 12.5 or 12.5. So my velocity is 12.5 or 12.5 feet per second. And you notice that I have that as a negative because I am falling. Okay, I'm descending. And we have one more, again, with that word function. Find the domain of the function. Remember that domain means x, and range is y. To find the domain, you must exclude any values for which the denominator, 1 minus x, is equal to 0. To do this, you need to solve the equation y minus x equals 0 and use mental math. So 1 minus x equals 0. So 1 minus what would give you 0? Well, 1 minus 1. So x is going to equal 1. And remember, x is your domain. So now that I've figured out that x is 1, I can plug it back in to the function. And y equals a negative x, so negative 1, over 1 minus a negative 1. Whoops, sorry about that. Let me do that again. So I have 1 minus, and my x is 1. So my numerator is going to be a negative 1. 1 minus 1 is 0. Okay, so that means that this is undefined. So it will not work if x equals 1. That's the exception to the rule, excluding or the exception. And that then will finish lesson 2.7.